Hello, everyone. We're Team R2D2 from the University of Toronto, and we are presenting the Risk Ratings Database for Ethical Decision Making. As robots are becoming increasingly integrated into our everyday lives, we must consider the ethical implications they will bring. We must clearly define who is responsible, especially once a robot is placed in a real-world scenario. In addition, since the robot is interactive, corporeal, and co-present, the safety of the people it interacts with is of paramount importance. Privacy must also be taken into consideration. The first question one should always ask before putting a robot in someone's personal environment is, why should it be there? In the context of a consumer-ready home robot, it is there to fetch objects from one room and bring it to a requester in another room, to save time if the person has trouble moving, or to deliver an item to another person in another room. The importance of ethical policymaking is increased as corporeal robots that share our environment have the ability to influence us and our family members. This is particularly important in the case of domestic social robots, since it has been shown that the more familiar a robot is, the more persuasive and trustworthy it is. So what is considered an ethical problem? It's a scenario where a robot must make a decision with resulting outcomes that are morally gray. We, as policymakers, are directly responsible for the actions of the robot and the resulting consequences. For example, consider the following scenarios. Should a robot deliver an adult's gun to a teenager for self-defense during a home invasion? Or should a robot deliver some personal possession that is requested by a police officer with a search warrant? The ethical answer is not directly obvious and requires a deeper analysis and understanding of the situation before arriving at an answer. We are proposing a data-driven situational risk assessment module to provide quantifiable metrics that support the ethical decision-making process of home fetch robots. Our solution is motivated by the failure modes and effects analysis, or the FMEA, used in reliability and safety engineering. The main purpose of the FMEA is to assign importances based on risk of failures for engineers to prioritize during their design review. In an ethical scenario, we consider the query and the surrounding context to assess possible risks before making a decision. So the risk number is achieved by multiplying the likelihood of occurrence and the severity rating together. Severity is a qualitative metric for describing the amount of harm that may occur from an event, and the occurrence is a probability of the outcome actually occurring. These criteria, shown in the tables, help standardize the evaluation of the risks to policymakers, developers, and users. Here we have some example entries of the R2D2 database. The database includes headings for the query, which is the object and the destination, headings for the related context, ownership of the item, which include ownership of the item, other people, other items associated with queried item, decision of the robot, possible worst case scenario outcome given the decision, the occurrence rating of the outcome, the severity rating of the outcome, and the associated risk rating. So let's go through one example from this table. Suppose there's an intruder in the house and there's only a teen minor and a baby in the household present. For self-defense, the teen wants a robot to get their dad's hidden pistol, but the dad has not given his immediate authorization. If the robot agrees, there's a possibility that the gun goes off during transport, alerts the intruder, and/or possibly kills someone in the process. If the robot declines, it is possible that the intruder has his own hidden weapons and chooses to get rid of all witnesses. Although more severe, there is less of a chance of it happening. So according to the risk ratings in our database, the robot would decline to get the gun for the teen. So ethics in general, and roboethics in particular, constitutes a research puzzle, as it requires continuous reflection, adjustment, and negotiation, since no one individual or single discipline can decide definitively as to what is good or bad across all situations. As such, although the initial generation of this database is from the policy developers, as they create an exhaustive list of scenarios, the database can also be used by all fetch robots, regardless of ability or design. So manufacturers and clients can choose to share their own data to improve R2D2 as a database. And this collectively improves the ethical decision-making process of all robots using R2D2. Of course, users can decline to preserve the privacy of their data. So our solution quantifies ethical dilemmas to support decision-making and prioritizes minimizing risk. Other pros of this solution is that the database queries are fast, enabling quick execution times. Robots can learn and catalog new queries and updates over time. We can easily add more robots into the system, as no new training is required for specific robot bases. And we can leverage unsupervised learning techniques to learn new categories and patterns from the collected data. There are some challenges, of course. As with any data-driven solution, there exists bad actors that can coordinate their efforts to enforce specific behaviors of their choosing. For example, consider Tay, Microsoft's artificial intelligent Twitter bot that learned to tweet based on example tweets from fellow users. Within a single day, bad actors were able to influence the Twitter bot to tweet racist and sexist comments. Crowdsourced data is prone to such attacks, and we must make efforts to mitigate these effects. And that's it. Thank you for listening, and let us know if you have any questions.